Good morning, everyone, and welcome to today's session, Getting to Continuous Deployment with Rainforest QA and CircleCI. My name is Krista Muir, and I'm Demand Gen Marketing Manager at Rainforest. Before I get started and introduce our speakers, I'd like to do a quick housekeeping round. Throughout our discussion today, please submit your questions in the lower left-hand box of the console. We'll have about 15 minutes or so for our speakers to answer those questions at the end of the presentation. We're also recording this session, so we'll be sure to send that to you later today along with the slides, and then we'll go ahead and get started. So continuous integration at this point may be a widely accepted practice, but it's just one step on the road towards the bigger goal of getting to continuous deployment. However, very few organizations have figured out how to get to CD without compromising quality. And to talk through some of these best practices, we have Kevin Bell and Fred Steven Smith. Kevin is the developer evangelist at CircleCI, and CircleCI is a continuous integration and deployment platform. Fred is our CEO and co-founder at Rainforest QA, which is a continuous QA platform. Fred, I'll go ahead and hand it off to you to get started.
Thank you, Krista. Hello, everybody. Let's hit slide 1 here. And just so everyone knows, Kevin's voice is the American one. I'm the English one. So I guess today we're going to be covering exactly what you see on this slide. We're going to spend some time on what is continuous deployment and why should you be doing it? Perhaps to give you a bit of ammunition to sell it to other people inside your company. Then we're going to cover really what we consider to be the 3 key requirements of doing continuous delivery well, which is infrastructure, culture, and testing. And then finally, as Krista said, we're going to leave some time at the end for kind of question and answer. This kind of webinar, we're going to keep things relatively high level during the presentation piece that Kevin and I do. This is planned to be one of a series of webinars, and so we'll get into kind of like the deeper dive stuff in later webinars, but we are going to leave the question and answer time for you guys to ask whatever you want, and so we're happy to kind of deep dive into specific areas then. So without further ado, let's get started here. So I guess, Kevin, first question to you, my friend. What is continuous deployment?
Okay, let me make sure to use my best American accent for this one. I think there's certainly a number of ways you can talk about it, but I guess my favorite at the moment is to think of continuous deployment as sort of just the natural extension of agile development and delivery practices beyond continuous integration. And what I mean by that, I guess, is that the idea of agile development in the first place is to ship sooner rather than later, to instead of do a bunch of upfront planning, build a thing and assume or hope or pray that that is the thing that you were supposed to build, to do a little bit, ship it, do a little bit more, ship it, and adjust and course correct along the way. So one of the key things that people talk about in the sort of implementation of an agile development methodology is flexible scope, fixed time flexible scope, right? You're going to ship every 2 weeks, you're going to ship every week or whatever your sprint time is. And flexible scope, though, basically means that you need to be able to ship at any time. You can't kind of say, oh, well, if I don't finish this feature, then we can't ship. That's not the idea. The idea is that you're going to ship on Friday or Monday or whatever it is. And the scope is what's flexible. So that kind of already entails a certain amount of being ready to ship at any time, always having your code base in good shape. People in an agile team shouldn't be saying things like, oh, we've got this big merge coming up, it's going to take all week, or oh, my code's on the floor, I can't, it's all over the place, I can't ship for 2 weeks. Those should not be acceptable in an agile development team. Continuous integration helps very much with that, making sure that tests always pass, that builds are done frequently. Ideally, you should be building not only on your sort of main line or on master, but you should be building on feature branches and testing on all of them, running as many of your tests as possible against as many of your changes as possible to get good fidelity view into things. But the next step after that is to actually go ahead and truly ship as frequently as you can. So not necessarily even constraining yourself to every 2 weeks, but to actually not just behave as if you might have to ship at any time, but to actually do it. And you might ask why. Well, I think that's the next slide.
Let's ask why. Why should we do this?
It's almost like I knew that was coming. So there are a number of reasons. It adds to the general Agile capability to validate things quickly, right? If you, let's say, to get to sort of a really extreme Agile cadence of maybe before I even build this thing, I just want to put a little, optional beta, sign up button here, or I want to just do some quick experiment or something. You can roll that out and test it for a week in the first half of a 2-week sprint if you're doing sprints or whatever. You can experiment with things much more freely and try things out in much more limited fashions. It just opens up tons of options that wouldn't otherwise be there to validate assumptions and test out functionality more quickly. More responsive to unforeseen problems. Anything, I mean, obviously, even in conventional deployments, it's common to do some kind of emergency bug fix deployment or have just some need for some unexpected things comes up and you have to address it. Well, you can only deploy bug fixes as fast as you can deploy. So if you are at a faster cadence of deploying already, then that means you can deploy bug fixes faster as well.
Right, and we're probably all familiar with the nightmare scenario of shipping a build, realizing something is broken in production, scrambling to get out a bug fix and realizing that makes things worse, right? And so the idea here is, okay, moving to this more continuous deployment cadence, we're actually set up to be able to deploy those kind of like rush fixes. That's how we do all deploys, and so therefore there's a much lower risk to doing it.
Right, and it makes deployment sort of a non-event. I mean, you shouldn't get anxious about deployments. A deployment shouldn't be this big thing where you have to drop everything just to get all hands on deck to accommodate an deployment. That makes just every deployment a higher risk endeavor. And on minimizing risk, if you're deploying more frequently, then that means there's less stuff in each deployment too. So I think my favorite way to think about this is each deployment should have a roughly understandable amount of change in it. If you deploy, some feature fix and change the language runtime, some new feature, a bug fix, change the language runtime, etc., all in one deployment, and that just hits your fleet at once, for example, and then some bug crops up, it's really hard to track down what could have caused that. If the bug is only in production and it didn't come up in any of your tests. Whereas if you're deploying a bit at a time, constantly rolling new things out, it just gives you a lot better insight into what might have caused a problem when. And just a lot more sort of tracking of everything. One caveat to this is that something we might get to on this call or on a future webinar is a discussion of feature flags, which does introduce one area where you need to be careful. If you have a big feature that gets turned on, that can be kind of like a big deployment. It can move a lot of stuff at once, and that's something that you want to monitor carefully and probably roll out gradually.
Let's talk a bit about how this relates to Agile, because we think of continuous deployment, right, as very much a continuation of the Agile philosophy, but applied to deployment. So help us understand how that kind of fits into the broader Agile story.
Yeah, so one way to think about it, I mean, like we have noted here, is that it keeps your process honest, right? So you can, in a, say, bi-weekly sprint mode, you can have some stuff in kind of a weird incoherent state in the UI on Wednesday, but you can fix it by Thursday and ship it Friday maybe, and that'll be okay. But if you're really deploying daily or multiple times a day, then that's just not acceptable. And in Agile, that's not good. You should know that things shouldn't be in some broken state in master for long at all in Agile in general. But if you're doing CD, then that just enforces that. Another way to think about CD is that it's just, it's expanding the scope of things that you approach in this Agile fashion. So instead of just covering your development process in an Agile way, you're extending that into deployment.
Awesome. So let's look at what we consider to be really at a high level the kind of 3 requirements for doing continuous deployment well, because I think to give a slight bit of framing here, both you and me, Kevin, spend a lot of our time helping our customers, our communities of our various the products that we build, helping those guys get to really high quality continuous deployment. And so along the way, we've seen a bunch of pitfalls that people tend to fall into. You guys don't really need me to necessarily read what it says on the slide, but as a kind of high level, we're going to cover infrastructure, culture, and testing. So let's dive straight into infrastructure here. So we consider, the infrastructure basics of continuous deployment to be these 4 things: version control, a continuous integration server, unit and integration testing, and then monitoring. So I think what would be interesting and probably helpful for everyone is just to go through, the kind of what and why for each of these. Kevin, do you want to handle version control? What is version control? Why should we be doing it?
Sure, and hopefully, this is something I can just kind of gloss over because I think it's established enough at this point. I think we all know the basic value of having a complete history of everything. Code is extremely information dense. If you're not tracking everything in version control, you're gonna end up, shooting yourself in the foot at some point. Every developer, if they don't have a version control system, they're doing version control with folders in some directory, and it gets crazy. A version control system is just a smarter way to do that. A distributed system like Git, or a distributed version control system like Git, has some other really cool benefits, like being able to have local branches and handle your own, for individual developers to handle their own development with branches as they please, and the sort of feature branch pull request model that has been popularized by GitHub, I think is definitely a boon as well to having a really nice collaborative agile process where you can integrate frequently, but with a lot of transparency and oversight at the same time.
Absolutely, yeah, and I think that's key to mention. We'll be getting a bit into this on the next slide when we get into kind of the culture required for continuous deployment. But I think it's worth pointing out that the pull request, that notion of a specific page that exists for a specific event of merging one piece of code into another, is totally crucial to this whole philosophy, right? This notion of being able to really check in an objective way, what are the changes that are being made here, what are the impacts on my testing, and what are the impacts on my code quality. That's a crucial part as well, right?
Definitely. There are ways to do it. There are other review tools. There are other version control systems that think about it differently. But that's certainly my favorite way. It's what we support best at CircleCI, and Rainforest QA might be a little more agnostic, but we certainly we love that.
Right.
It makes that integration of code into the main line a kind of constant event that's done in the public eye, so to speak. At least within your team, and it lets you get a lot of buy-in on every change that's made. Often, even for trivial changes that even if it's like a little just one-liner typo documentation fix or something, we still just make a quick pull request and merge it, maybe even without code review in that case, but just because it's transparent and lets everybody get a
and it gives you this history, right? You can look through every single pull request and see the history of what's been added.
Sure.
The other beautiful thing about pull requests is that most of our customers, and of course we, and I'm sure you guys, we have our continuous integration server actually connected to our pull request system, so that on every pull request all of our integration tests are run and the results are fed back directly into GitHub pull request UI. So that's a decent segue into a CI server. Kevin, in your least subjective way possible, can you describe to us what is a CI server? Why should you use one?
Sure. So I think the minimum, at a minimum, what a CI server should do is pull down the latest code, at a minimum from your master branch or something, but hopefully from all the branches that everybody is pushing to, and run your tests on a centralized server, preferably with a fresh environment every time, without any kind of cruft accumulating from previous builds. To ensure that while the tests might pass locally, they pass on CI as well. And from support experience at CircleCI and so forth, I can tell you there are so many things that can go wrong on CI that work locally, or that is to say, so many things that can seem to work that can magically work on a developer's box that do not work in CI, let alone production. Right? everything from file ordering bugs in Ruby, where you get some things magically included from some previous file, or there's just so many things that can go wrong. It's really crucial to test in a centralized environment and to have your artifacts, your deployment artifacts, whether that's a jar file or a war file or a Python wheel or a Docker container, whatever it is, to have those generated from some kind of sterile controlled environment is really crucial. So automating all that is the minimum of what a CI server should do. But as we talk more about deployment, they kind of can evolve into everything between your version control and your production system. So they can tie together everything from, okay, a change was made in the code, they can pull that down, validate it, build it, test it, and turn that into some kind of production-facing artifact and trigger the deployment onto your production infrastructure, whether that's Heroku or something on AWS or your own hardware or a Docker fleet or whatever it is.
Right, because we haven't actually put that in the slide, but really, at least half of the value that we get from using CircleCI, for example, is the deployment aspect as well as the kind of CI aspect.
Yeah, and I guess production isn't production hosting isn't on here. I guess that's sort of an implicit thing that exists already, or that has to be there, right? We're kind of assuming maybe web apps here, but basically all this could apply to mobile apps as well. I mean,
right.
Mobile apps with an API, you can have your Crashlytics or your whatever mobile kind of solution for things like monitoring as well. So
right.
Most of this is pretty universal.
And so high level, I think we've got kind of pretty deep into the what, but in a very succinct way, why should we be using a CI server?
I think that, let's see, this centralized validation of code is the key that you're not going to get without it. Once you're in a team, it just becomes, as soon as you go from 1 to 2 people, it becomes crucial to be running your tests and validating your builds in a centralized way and not just locally. And once you move towards a CD workflow, it becomes a crucial component to the overall CD infrastructure as well.
Awesome. So testing, right? Something that obviously is very close to my heart working at Rainforest is testing. A huge part of what you guys do on the CI side is running people's tests in a very efficient and fast manner, right? So let's talk a bit about that. What are we talking about here in terms of testing? We get deeper into this later on, but at a high level, what are we talking about, and why should you be testing it as part of your CD infrastructure?
Yeah, I think let's see. We will talk more about testing in a little bit, but basically, the testing from an infrastructure perspective, you should just avail yourself of all of the wide array of testing tools out there to make your life easier and enable you to build better quality code, whether that's using unit test solutions, functional testing, sort of more black box testing solutions in an automated fashion using browser testing tools, or with something more hybrid like Rainforest QA. There's a whole spectrum of types of tests out there, and we'll talk more about that later, and a whole spectrum of products and tools to match. I think
in essence, we want to do testing because we want to rely as little as possible on the fallibility of humans, right? Like from a philosophical standpoint, that's kind of why we're doing testing.
Sure, yeah. Automate. You should have as much as possible. You should be able to just run your test suite, your automated test suite, and that should give you a good degree of confidence. If it doesn't, then it's not a great test suite.
So onto monitoring. Monitoring is something that's usually or often forgotten in the discussion about continuous delivery, deployment. Something that we hear a lot from our customers is like, well, what do we do, once this goes out if there's a problem, right? And so that's really the key piece here. We think of monitoring in the infrastructure stack as like something that if everything else fails, really just kind of saves your bacon once that problematic code hits production. You want to touch a little bit on that?
Sure. I guess the main thing I would add is that unexpected things will come up in production. That will happen. And so the question is, how can you best handle that when it does happen? And if you deploy slowly, then a production issue means an emergency, right? How often have you experienced in companies that deploy less frequently, oh no, there's a big issue in production, we need to drop everything and handle this. If you're already deploying daily or more, then some issue cropping up in production is kind of just another thing to address, yes, with a heightened urgency, but you can use the normal deployment mechanism for it. These, tools though, something along the lines of New Relic or App Dynamics can be really cool to sort of not just get pure errors, but to see live performance monitoring in production and get sort of a leading indicator, hopefully, of something going a little bit sideways. Why does this thing just take a bit slower than it should? That feature should have been a no-op in terms of performance. Why is this slower? And then you can dig into it, and you can get a lot more granularity into all that stuff if you're deploying features on a one-by-one basis as well.
Awesome. So let's look at the culture required to do continuous deployment. Now, to give a bit of an introduction here, I think I touched on it earlier, but this slide may seem incongruous to some of you. Why on earth are we talking about culture? We're supposed to be talking about continuous deployment here. But something that when Kevin and I were discussing, what to cover is kind of the fundamental building blocks of continuous deployment, something that came up for both of us time and time again was the number of customers that we'd seen who'd implemented the infrastructure brilliantly and who had, great test suites and who had all of the kind of high-level stuff in place, but they hadn't changed their culture over from an older culture of less trust and less agility, especially in their development organization. And so that's something that we think is hugely important, and so therefore we wanted to touch on this to help you avoid making those same mistakes. So let's talk about it. Trust your team is obviously the major key here. What are some examples that you've seen in the past where this has kind of got people into trouble?
I'd say, from my perspective, recently at CircleCI, it kind of it does come up occasionally. Customers will ask for some kind of advice on how to lock down a particular kind of functionality or a certain type of test even, or something that they don't want developers to be able to do. And it always makes me think, how little do you think of your developers, or how little trust do you have for your developers? Developing software is implicitly a very high trust activity. You're trusting your developers to do really important stuff and to build code that will run on people's computers, and that's kind of a big burden. You should be aware of that and give them explicit trust as well, and appreciate kind of what goes into software development. I think
it feeds nicely into the code review process, right? Because something that we see a lot is that the code review is an essential part of doing continuous deployment. Ultimately, as the VP engineering, as the CTO, or as someone who is ultimately reporting to those people, you need to be able to trust that when you choose to deploy a new code to production, that's not going to take down everything, that it's not going to break things, right? And that trust is so essential to being able to do continuous deployment, because it means that the more trust there is within your organization, the faster you guys can move, because you'll all be comfortable doing that, right?
Sure, yeah.
So let's talk a bit about that. Tell me about trust in the code review.
Yes, this is. We were talking a little bit about this earlier. This is something where some organizations seem to kind of, limit the code reviewer as sort of this exalted position that only the team lead or something can do. But
right.
It's really, we use the term. I think it came from Google originally. The abbreviation LGTM just looks good to me, which is kind of fun because it takes a little bit of the pressure out of the code review process. Lately, we've also started occasionally substituting in IGYB. That's I got your back. But it's just, our requirement is another developer needs to sign off on it,
right.
And that should be a bar for your developers, in your organization, is that you should trust them to do code reviews, and it's a great way to learn as well. So,
right.
It's one of the best ways to level up as a developer is to read other people's code, more senior people's code, etc. So that should be just part and parcel to the process.
And I think it's also about moving away from this notion of each piece of code being a territorial exercise that one person owns, right? The ideal development organization, in my eyes at least, is one where any developer is comfortable working on any part of the code base that he is able to.
Absolutely.
Right? That there's no cultural blocks or checks in the way that stop you from being able to, say, go in and edit a piece of code that was written by the most senior engineer on your team, for example.
Yeah, for sure.
So, involving developers closely in production operations. What do you mean by this? This
Yeah,
is something close to your heart. Right?
Yeah, kind of two things, I guess. One is it should benefit the developer in that the developer should have the ability, I think, in a healthy CD process to be able to take some new feature or bug fix in development and kind of selectively expose it to some tiny percentage of production traffic and ramp that up slightly and just see how it does in production, because like we talked about earlier, unexpected things will happen in production. So, doing this kind of thing isn't to say that, oh, my QA is my users. That's silly. That's not what you're doing. You're just getting a wide array of input data. Potentially, you could even use tools to record production data and then replay that recorded production data against a new feature instead of actually exposing it to handling live requests. There's lots of nuances you could do on it, but there should be an ability for developers to vet things in development against production, and then it should benefit the the ops or the DevOps or the deployment types of teams in that they should feel free to pull developers in to help them with issues. If the stack trace points to a certain developer's line of code and you get blamed them or whatever, they should be happy to help out. They shouldn't feel defensive and like, oh well, it passed all the tests or it passed code review, so it's not my fault. You should be very collaborative in this process.
Right.
And again, it's a case of trust that can go both ways and really just be only a good thing.
And I think the key thing as well for us is that you don't end up with these silos within your organization, right? Like the notion of doing continuous deployment really well relies upon a lot of collaboration between people, right? And something that we see very often, of course, because of our, proximity to the QA process, is that a QA team is basically siloed away from the rest of development, and people are like, okay, this is ready to be QA'd, go and do it, hurry up, right? Mm-hmm. I think the same thing applies to, bad software organizations with regards to ops, right? Like the operations team is like this siloed thing, and once developers think they're ready to deploy, they throw it over the wall, and what you hear is, well, it worked for me, right?
Yeah.
And so I think that's something that we both agree is absolutely crucial to avoid. We already touched on this, so it's slightly out of order, but is there anything else we want to add on kind of reviewing pull requests?
I think we kind of covered it. Like you mentioned, status on GitHub is amazing. I mean, that's a great tool to
just explain for people that don't know what GitHub.
Yeah, good point. So I mean, GitHub, if you don't use it day to day, provides a page which is basically, you can think of it as the merge review page or the code review page. It's a lightweight code review tool as well as being just a piece of the UI to interact with GitHub, but it displays a status message that says your tests either passed or failed on CI. There could be, if you have separate CircleCI tests and Rainforest QA tests, you can get multiple entries, one for each of those, and that gives you some focus where to look. CircleCI takes this even a little bit further, and for example, the CircleCI UI says this exact test failed at this spot and gave this output, so that developers can just quickly dive into that, and it's kind of highlighted. I'm sure Rainforest QA suite will give you the same kind of insight.
Yep. Awesome. Okay, so then, let's look at the kind of final piece that we think is super crucial to doing continuous deployment well, which is, of course, testing. We've put test continuously up there, and I think a crucial part for us of this kind of philosophy here is that the burden of testing should be almost nothing, right? You should be able to test everything. Whenever you want, right? And in an ideal world, any developer feels empowered to test any piece of their work at any point, right? And so I think the crucial thing here is being able to test continuously. We've also have this little graphic here showing what some people call shift left. It's this notion of, rather than having this real siloed QA process where your development and product teams build out a product and then say, okay, now test it, right? You can guess what that leads to, right? It leads to a whole bunch of problems being found and then all of these horrible, costly iterations. Mm-hmm. Now, guess what? That's the usual way to develop software today. We think that continuous deployment is a better way, in part because it forces you to push your testing earlier into the process, and so you uncover these problems earlier, and so there's less of this kind of like bottlenecked, gated methodology, right? So that's a kind of maybe just a slight bit of framing there. can we talk through what these different kinds of testing are? So what is a unit test? Why do we do it?
Sure. So unit tests are tests that you write along with, or some would assert before the application code. And the idea is that developers do this. This isn't a job for a separate test team. Developers write these tests along with the production code, and it's code to test other code. And this is. These are good for often catching edge cases that developers know intuitively about. They know to look for these things. So what happens if this function gets 0 or a negative number or a really high number, or does it handle, is the 8-bit integer going to wrap or whatever? They know what kind of edge cases to look for, which is a different class of errors than what will come up in functional tests or exploratory tests, or that a human might look for. So these are great and critical, and they often serve another purpose of giving you insight into the actual quality of your code base. If you have to write some kind of triply nested weird mock thing to test some code, that's probably not great code, and that gives you a bit of insight into how to structure your code. So it's great for that too.
And so you said earlier when we were talking about this, your unit tests kind of also serve as documentation, right? Like when you go to an open source project, you're apt to look at the unit tests themselves to understand what the code is trying to do.
Yeah, for sure. I mean, ideally there's some documentation or a README or some other stuff for developers to collaborate on besides just tests, but often tests are a great tool to get a bit of documentation for free. And yeah, it's always my go-to thing to understand how some, whether it's a class or a namespace or a function works, is to just look at what are the test cases used against it, and it's a great tool for that.
Right. And we might cover in a later webinar, TDD in detail, but without going too far into that, I think we're both agreed that writing unit tests is a really crucial part of writing good code.
For sure.
Right? And so the notion of having your unit tests always up to date and relying on your unit test to tell you, is this good or not, is a fundamental part of continuous deployment, right? Because we use continuous integration. At Rainforest, we use Circle. And so every single commit anyone on our team makes, we see immediately, has that broken anything in the unit tests? And that gives us this amazing insight into, across now, 15 developers, in a way that no individual human would ever be able to comprehend themselves. That gives us amazing insight into where are we at in terms of quality, and is this deployable right?
Yeah, they can also give you can use them in conjunction with, say, a bug report, right? If you can produce the bug report as a failing unit test, then that's a great way to document and enshrine that bug forever in your code base, or at least as long as the code works like it does, to say this edge case was found by a user and ultimately boiled down to this weird failure mode, and now it's one of your unit tests and you can check it in a microsecond.
Right.
So that's great.
So unit testing is kind of looking at your application, looking at your software from kind of the ground up, right? We're looking at the individual units of code, and we're testing them, in a very isolated way. The other key part of testing, if you're thinking about this visual metaphor, is testing from the top down. What we call UI tests. People call these very many different things. Some people call them integration tests, some people call them regressions, some people call them functional. But ultimately it's about testing the interface that your customers are also going to use, right? So at a high level, just walk us through this. What are we talking about here?
Yeah, so like you said, there's a handful of things. There can be, integration tests between services that are not necessarily human-facing or user-facing, but one that people talk about often is UI testing, which could be using browser-driving tools like Selenium or things of that nature, or in mobile apps, something like Appium, where you're really doing your best to simulate as much as possible a user doing things. There are a lot of tools and frameworks to help with this. It's a very powerful tool. If you're, for example, an e-commerce site, you will certainly want some of these for your shopping cart, checkout workflows. If you're anyone with a sign-up workflow or a contact us for enterprise sales or whatever workflow, you will definitely want automated tests for those that are really bulletproof, because those are so business critical, right?
Right.
I would say where they fail most is for visual type of stuff, which is one of the most important things to users, but one of the most difficult to test in an automated fashion, right? There are such things as automated visual tests, but they're very brittle in my experience. Things like, this button looks squished, or this button is white so I can't even see it. Those are the kinds of things that, humans are just going to be better at finding.
Right. And so I think the key thing here is to have a pragmatic balance between the two, right? So I think, what's important, and I'm seeing some questions coming in kind of pertaining to this, what's important is that your testing strategy is realistic, right? So what we often see is that someone has created, an engineering team has decided to go to town on automation, right? And so they've gone and they've created 1,000 automated tests to cover all of their, what they consider to be their core customer flows. And the problem with that is that someone then has to dedicate a lot of time to keeping those up to date. And so, I'm sure many of you currently on the call have experienced this in the past where, you have a suite of automated tests, and over time people start ignoring them because they start failing more frequently, and it just gets into this kind of cycle where, they aren't a very strong signal. I think the most important thing as far as we're concerned with testing is that you can really trust the results of your tests. And so if there's a failure in any of your tests, that is enough to say, I shouldn't deploy right now, right? And so I think for us, the key thing is to have those kind of deterministic results and a nice balance of don't test everything, test the things that are important and that you can test in a leveraged way, and rely on the kind of UI testing to cover some of the other holes that aren't necessarily as deeply tested as
being in a spot where you don't trust your test suite is definitely a slippery slope of, I can ignore these tests because that's flaky, and then, that's bad because, you don't trust your test suite, you don't rely on it as a tool to gate your deployments. Right. And also, like I think we kind of explained, this is not an either-or choice. I mean, both these things go both automated and something more hybrid like Rainforest QA. Those can be used in a very complementary way. One of our very prominent joint customers, Zenefits, is a good example of someone that uses both of us extensively to do both automated and hybrid tests together. They can work together, for sure.
Absolutely. So I think then the final thing we want to cover on this slide is the production monitoring and rollbacks piece. This is something that we get asked about a lot, and I think the key kind of philosophical underpinning of this is that problems are always going to get through, right? Production is its own strange beast, which may or may not cause its own unique kind of problems. Sometimes a microservice or a API that your application depends upon that you do not develop and you do not deploy can go down. There's all kinds of different scenarios where things can get messed up in production, and that's why we do production monitoring, right?
Yeah, absolutely. I mean, I think I probably already said 3 times that things will happen in production that you can't expect, right? Again, for those just business critical components of your site that cannot go down, or if they go down, it's a $1 million a day problem. That's where you really want to just monitor that at all costs. And again, you have a whole spectrum of tools available for this. You can ping, you can create a pinging endpoint, or a heartbeat endpoint that just does some internal health checks. That would be kind of like the unit test of monitoring, right? Checking code that checks itself from the inside out. You could have just some HTTP level request that makes sure that a response looks right. You can have an automated browser type of test that clicks on a couple things and makes sure things look right in production. And you can have something like what Rainforest QA would do with people to do a more human-based check.
Exactly. I mean, you said it better than I could have. So that's about it for our little presentation there. In summary, oh wait, and you know what's funny?
Genuine surprise.
That was genuine surprise. I thought in the little preview that was a conclusion slide, and in fact, I just
good thing we titled it just like that.
Yeah. So, but wait, other things to consider.
Yeah. So I insisted this slide be here just because I talked earlier. We kind of covered a lot of things, but I talked earlier about how continuous deployment is really just an extrapolation of what you're already doing with a good agile process. It's just taking things to the next step from being in a state of being able to deploy every day to actually deploying every day. And it's in many ways a smooth transition. You should just do all the stuff you're already doing just more and better, and it'll generally lead to continuous deployment. There are some exceptions though of sort of emergent things that just come up when you deploy as frequently as in a CD workflow. your deployments really have to be zero downtime. I mean, once you get to multiple per day or tens per day, you really can't have 30-second outages when you're deploying. And especially in a SOA type of architecture where you've got 10 different interdependent services, each being deployed 10 times a day. If you just do the math, your nines of uptime quickly plummet as these each start to be offline for a few seconds at a time. So things have to be truly zero downtime. That's its own whole other topic, but it's good to be aware of. Feature flags are going to be an indispensable tool for, like I talked about earlier, the cases where the UI would be half broken or it's half done for some new feature. I saw a question in the side there about how do you test features that take a long time to develop, or sorry, how do you deploy them continuously? You can keep it blocked off behind a feature page for a while. The code can be in place. You can kind of look at the half-done feature and UI in your in the developer or the tester's own view of the app where they have it enabled, and you can do things like have optional beta testers, or let your customers opt into this new feature when it's kind of still a little half-baked, even in production, and they can choose to see this brand new feature. Lots of people love to do that, so feature flags are great for that. And then gradual rollouts, these can be used in conjunction with feature flags so that you automatically turn the feature flag on for a growing percentage of users. That's one option, but it can also be used for non-customer facing things. Like if you're changing the JVM from version 7 to 8 or something, that's a huge thing, and you want to be really careful about that. That's so fundamental to the operation of your product. It's very beneficial to expose that to a little bit of production traffic at a time. And make sure that you're not getting any adverse reactions as that goes. So those are all things that kind of you'll want to think about and address if you really adopt continuous deployment, but they're all kind of their own whole topic.
And we're happy to get into those on a later webinar, and in fact we might even have a webinar to do that with some friends who do feature flags.
Oh.
So awesome. Thank you, Kevin. Thank you, everybody, for listening. We now have about 20 minutes allocated for questions here. Do you want to kind of tag team things and
let's
choose a question each to go through? So Jeff Jones says, does continuous deployment primarily apply to server-side components, or does it apply to client, e.g. desktop components also? Sounds like one for you, Kevin.
Let's see. So it's a really interesting question. The world of software is in a very kind of interesting place as far as this goes. There are tools to develop client, sort of desktop type applications that are actually kind of deployed in an evergreen way. Chrome is a good example of one that you'll kind of notice that it'll kind of let you know that an update is available. So you actually can. You can deploy very frequently to even desktop applications, depending on the type of application. Mobile apps are another example where there might still be things like an app store review process that could take a couple of weeks, but you can do things like basically do everything about continuous deployment, but deploy to a group of beta testers in the case of mobile apps using tools like Hockey App or TestFlight. So you can do all of the same deployment process to a limited group of users, and then it'll just be that final production deployment that is kind of gated every couple of weeks to some extent by something like an app store process. You can also, in the case of mobile apps, deploy the API backend continuously, but still be a little bit more limited in how you can deploy the client.
Awesome. So second question here, how can you have automated functional tests before the new feature is developed? This is a great question, and I'm happy to take that. The short version is you can't really have automated functional tests if you're saying that this relies on the DOM where the DOM doesn't yet exist. So that's the short version of that answer. The more complete version of that answer, though, is if you're using something like a Rainforest, or you're using something a bit similar, like, for example, a capybara or a cucumber, you can actually start to write out the user flow and the expected things that should succeed as part of that user flow before you've actually written the feature and before your developers have committed any code. In fact, that's what we recommend most people do, right? And you'll probably find that if you have product managers already in place, you'll probably find that they're doing something like this already, right?
Yeah.
They're already doing some sort of, in air quotes, QA on the actual specs before those specs have any code written against them.
And I think, a relevant buzzword might be BDD, or behavior-driven development. I think, is that the right term for Cucumber, I suppose, where you kind of write out some English language description of things and then map that to the application.
Absolutely. So Jeremy Ward says, this is for you.
Yeah.
Jeremy Ward says, what are your recommendations for cross-browser testing using CircleCI?
Sure. So in the case of CircleCI, first of all, cross-browser testing, definitely a great thing to do. Things are a little bit brighter now than they were 5-10 years ago in terms of cross-browser support. There's much more kind of convergence on supporting the same features, but still think there are definitely browser-specific bugs. And again, this is one of those things where you might kind of want to look at the ROI you're getting out of cross-browser testing. If you do all of your functional tests against every browser on every operating system, that's obviously a huge multiplication of factors. But those critical flows, right? Those signups, those checkouts, you likely do want to do that, depending on if you feel you get an ROI from it. On CircleCI, we support, in terms of major browsers, Chrome and Firefox out of the box. If you want to expand to things like Safari, Internet Explorer, different operating system versions, then you would want to look into something like a Sauce Labs or a browser stack that lets you kind of do that against some remote service.
Or Rainforest.
Or there's this other one, Fred, that you have pretty cross-browser support as well, right?
We do, yes, and cross-platform.
And you can call Rainforest. So my point is, Sauce Labs, browser stack, Rainforest QA, you can call these things using APIs from CircleCI. So CircleCI can drive the process, but the actual executor of the tests can be one of those other tools.
Yes. So let me summarize this question here, because this is getting into a bit of a longer question. So this is from Andrew Stearns. I hope I pronounced your name correctly. I'm looking to implement TDD and CI and increase testing in the development environment. Are there best practices to show how we have moved the needle, or what types of metrics do we need to capture to show that? For example, defection detection times. Great question, Andrew. And if you don't mind me summarizing this, which I will anyway, basically what we're trying to get to here is, how does one justify to the rest of the team, to management, etc., that this is actually a good idea and that we're actually pushing things forward, right? How do we actually measure the impact of doing CI and CD, right? Kevin.
Oh man, Fred, that's a great question. I think
actually Andrew asked the question.
Thanks, Andrew via Fred. So yeah, I think this is a great place where you should involve your product team, your growth, marketing, other teams with your discussions about your deployment process and how you can all kind of measure and think about this stuff together. Because if this is all purely software development inside baseball, that's not going to justify itself to management, to stakeholders. So work with product management to talk about how you can measure your output and see what you're getting out of CD. In the case of even sort of promotions for more marketing-ish stuff or promoting signups, doing experiments to do things like drip email campaigns or things that are very clearly tied to revenue. See how your CD process can help you with those. I think every company is going to have its own sort of distinct metrics depending on their industry, but I would say whatever metrics are already of concern or interest to you, you should just track those in the in a CD enabled world and see where that gets you.
Awesome. So this is going to be the last question that we answer. We still have a bunch more questions, so maybe we can do some sort of follow-up, or you and me can record something offline, or whatever. We'll figure something out there, guys, so we won't leave these questions unanswered. So the last question is from Nital Patel. And so basically he has a pretty long question and I like it, so I'm going to read it for you, and I'm going to answer it as well. So CD requires 100% automated testing. My question is, how can you automate UI-based functionality by a QA person in parallel with development? Currently, we use Selenium, which we have to wait until the dev team finishes their work. Then we find objects in the UI and write methods to act on those objects, which prevents us from doing CD. You mentioned automated test suites, but that in itself takes time to build. Great question, Ital, and Rainforest is something that actually aims to solve this exact problem. Can you imagine that I chose to answer your question? So, yeah, you're absolutely right, and this is something we touched on a bit just slightly earlier there, which was just that, you know, one of the things with automation is, as you said, it requires, you know, these elements to be present in the DOM in order to write the automation against. So, I think something that we see as crucial is being able to start to do the testing of the feature before you necessarily have anything in the DOM to test against. You know, like we said a bit earlier, there's various different ways you can do that. You could use, you know, something like a cucumber, right, where your product teams, your developers collaborate together to figure out how should this feature work in actually quite a granular fashion, right? So the user should do X, then do Y, then do Z, and then this should happen, right? This result should occur. And so, you know, I think that what's really important is that you have the ability to do that kind of QA on, let's call them the specifications or the requirements of the feature, and that starts to give you some level of confidence that you're on the right track. The next thing as well is that, you know, something that we've seen a lot of our customers do, and just to give you a quick, you know, pitch of Rainforest, what we do is simply send human testers to test your application, but we send them in vast quantities in parallel so that it's fast enough to kind of work alongside continuous deployment. And what a lot of our customers do is they write Rainforest tests that look basically like, you know, a user story or a set of requirements, and they'll run those tests against even a very immature feature once the developers have only just started working on it, to give themselves an objective sense of where are we in terms of being kind of quality complete. So this is something we could spend a year talking about, but that's basically the high level, right? You're going to have different testing philosophies to cover different parts of the life cycle. And that's also why you'll want to use unit testing. It's why you'll want to use some kind of hybrid stuff like a Rainforest or a Cucumber. And it's also why automation is important, you know, longer term once that feature is mature, because then you don't have to invest a lot of resources every single time you deploy.
I have one quick thing to add onto my last answer, because I was sitting there stewing on it as Fred was giving his elevator pitch. So I saw a couple more questions scroll by about KPIs, metrics, how do you measure the value of CD? Another really good one, I think, is, and this is kind of more, again, on the product management side, how many ideas can you throw away or disprove? This is a great tool for product managers to think about, right? How quickly can you vet ideas that you can have, you know, 50 and throw away 45 of them? When I say throw away, I mean test, you know, try to validate them. Do something in the app, build a little opt-in beta program, a sign-up option, even like a trapdoor or a kind of automated email or something that's a minimum or true MVP implementation of that feature, which you can deploy very quickly with CD. You can do this kind of process much faster than you could with, you know, slower deployments. See how many features you can, you know, discard as not the best, and then what remains will be better. That's another great, you know, tool to think about in sort of a product management sense that is very much enabled by CD.
Awesome. Well, Kevin, thank you very much. I would clap if that wouldn't just be one person clapping. Thank you guys very much for listening. I guess the timing is good, so thank you very much. This has been fun.
Thanks again, you guys. We'll also be sending the recording and the slides to you later today, so get excited. Thanks so much. Have a great day.